Hello, my name is Professor Amir Tomer, and this is one of the webinars in my series on software-intensive systems engineering. It is dedicated to use cases, and in this seminar I would like to show you some new observations about the good old use cases that we already know, and we call it making use cases great again. Let me introduce myself in short. I have an industrial experience of over 25 years in Rafael, the Advanced Defense Systems Limited in Israel. And during these years, I did a lot of jobs, including 7 years being the company director of software and systems engineering processes, where I was involved in defining the engineering processes for software engineering and systems engineering. I also have vast academic experience. Since 2009, during the last 10, 11 years, I've been the head of the software engineering department in Kinneret College on the Sea of the Galilee, in Jordan Valley in Israel. But since 1994 until now, I am serving as a senior lecturer at the Technion at Haifa, Israel. And I also delivered a lot of courses in other academic institutes and in industrial companies, industrial associations, etc. I'm doing research. I'm very much interested in software-intensive systems engineering, especially in model-based system and software engineering, especially in the intertwining between systems engineers and software engineers. And I'm also involved in research in software reuse. I'm currently a member of two professional associations. One is the Israeli Chamber of Information Technology, where I am a member of the presidency and I'm the head of the academic license and accreditation committee. And also in the Israeli Society for Systems Engineering, where I am the journal editor of The Voice of the System, a biannual journal. And at this job, I'm also a non-voting member of the presidency. So before we start, I want to ask you a question. What is your experience in writing use cases? Well, if you are experienced and you have written a lot of use cases, you would appreciate much of the things, of the observations that we'll show here in this seminar. But if you are not experienced in use cases, try to follow and catch up and see if it makes you attached to the idea of writing use cases, where you can find a lot of material on how to do it and all the technical stuff. So let's talk about the system first. System in its environment. Every system has an environment. What's the environment of a system? For example, look at the navigation system. Navigation system like Waze or Google Maps is composed of three major types of entities in the environment. There are the users. They are sometimes called, or in the use case language, they are called the primary actors. For example, the car driver. These are entities who interact with the system in order to achieve something. They want to do something with the system because they need something from the system. So these are the users. Another type of entities are supporters. In the use case language, they are called also supporting actors. For example, the GPS satellites, who provide the location of the car. Entities, these are the supporting actors, are entities whom the system interacts with. So they don't initiate the interaction, but the system interacts with them in order to help the system to do its tasks. Because the system lacks some capabilities, and these capabilities are provided by this supporting environment, supporting actors. But there is another section or another category of the environment. These are other operational stakeholders. For example, other drivers that are connected to the same system. These are entities who do not interact with the system, so they are not active, but they get benefits from its operation. For example, if I drive and I report about something, some obstacle on the area, or the system indicates that I'm driving slow and then there might be a traffic jam, then all the other drivers who are informed, they do not play with me in the navigation operation, but they benefit from the fact that I am navigating. So these are also operational stakeholders. In UML, a modeling language, there is a model called a use case diagram, which is a representation of the system in its environment. And it contains usually the following features. First of all, there is a system boundary. We're talking about navigation system. This is very important to draw the boundary and to define what is the system that we are talking about, and we'll come to this issue later. Now there are use cases. Here we have only one, navigate to destination. It can be considered as a service of the system or a task performed by a system, but in this language it's called the use case. Now, the driver is a primary actor, and the number 1 here indicates that there is only one person operating a navigation. Now, it's not a shared task, it's one driver operating a navigation, okay? And the arrow indicates that the driver is the primary actor, and he initiates the navigation. Now, throughout the navigation, the location needs to be indicated all the time. So there are supporting actors, which are GPS satellite. The numbers here, or what's called the multiplicity here, says that there must be at least 4 GPS satellites in order to provide the location, but it's not limited. There can be more, but at least 4. And the third category of the environment, the other drivers or the stakeholders, can also be symboled by this stick figure, operational stakeholders, but the relations with the system is that the system, or this use case particularly, the navigate to destination, satisfies the needs of other drivers, and there could be 0 or more, unlimited number of drivers who can benefit from the navigation of that one driver. So please note, the arrow direction indicates the activation, which means the driver activates the system, but the system initiates the activation of the GPS satellite. So it collects data from the satellites, okay? And the stakeholders, they are associated or connected to the system by a dependency. This dashed arrow means dependency in use case language, in the UML language. And this says that the use case depends on the stakeholder because it has to satisfy. If something is changed with the needs of the other drivers, then this use case will need to change as well. This is the meaning of dependency. Now another question. If you look back at this use case diagram, it's certainly related to the processes the system has to do. But is it a behavioral model? Look again. Does it contain or does it specify how the system reacts or how the system operates? Well, Certainly not. The use case diagram itself is not a behavioral model, although it is considered as one of the set of dynamic or behavioral models of the system. But the diagram itself is not a behavioral model, it's not a behavioral diagram. The use case diagram is a static model, nothing changes here. This is fixed situation, and therefore it cannot represent dynamic behavior. Nothing happens here. So the diagram, what does it contain, usually, really? It contains a set of use cases, a set of tasks, a set of services, a set of actors, a set of stakeholders, and some relations between those sets. There are relations that are not shown here, that can be relations between actors or between use cases, but for the brevity of this, we'll see only this, the relations that are shown here. And but this is a static model. In order to know or to understand what the system does or how the system behaves, we need to specify specifically the behavior of the system throughout every use case. Every use case needs to specify how it operates from the beginning, when the actor initiates it, until the end of it. It can be specified as textual description. It can be specified by other diagrams, like activity diagram or a flowchart, by sequence diagram that we'll see later, which is activity diagram between entities, but it should be somehow modeled. It is not modeled here in the sequence diagram. So before we go to how we specify the activity itself, let's ask a question. A use case, a system task, a system service, does it have to have at least one primary actor, somebody or some entity in the external environment that initiates it? Think about it. Well, the answer is not necessarily. There could be use cases without primary actors. Take a typical example. Suppose that you have a system that has a use case that is named perform a periodic beat. So every now and then, every few seconds or minutes, something happens in the system that initiates a process that's called a periodic built-in test, that goes around and checks all the parts of the system and checks that everything is all right. Now, this use case is certainly invoked spontaneously by an internal event in the system. There is nobody from the outside that initiates it. Such use cases are called spontaneous or internal. So there could be use cases that are not initiated by the external environment, but they are initiated by the system itself. However, there must be at least one stakeholder. Well, if there is an actor, then the actor benefits from getting the goal, arriving at the goal that he needs from the use case. But if there is no primary actor, then there must be at least one stakeholder that benefits. Because if nobody benefits from this use case, why is it performed at all? So it can be called a useless case, which means do something for no one. If it does something for no one, then why should it do it? Okay? Now, take it a little bit inside. Think about an alarm system, a burglary alarm system. A burglary alarm system is a system that blows the horn and also contacts a center, a report center or a guard center when it indicates a burglary. Now, the burglar that enters the system, is it a user or an actor of the system? A primary actor? Well, it's sometimes surprising to see that a burglar is not a primary actor of an alarm system. And why is that? Well, a burglar activates the alarm system, so it might be considered a primary actor. But think about these things. Other entities might as well activate the alarm. A cat may activate the alarm. A curtain that moves may activate the alarm. A lightning can activate the alarm. And also a spot on the detector can activate the alarm. So are all these primary actors? It's ridiculous to say that a spot on the detector is an actor. So what is an actor? A burglar, another issue, that a burglar does not initiate the alarm activation in order to achieve. את השקופית הזאת צריך להתחיל מההתחלה. Well, the answer might be somehow surprising. A burglar is not a primary actor of an alarm system. Why is that? First of all, a burglar activates the alarm system, so it might be considered a primary actor because he activates it. But think about this. There are other entities that might as well activate the alarm. A cat may activate a burglary alarm, a curtain that moves in the wind, a lightning, or a spot on the detector. Now, are all these primary actors? This is somehow bizarre to say that a spot on the detector is a primary actor. Now, a second point. A burglar activates the alarm, but it does not initiate the alarm activation in order to achieve something. To the contrary, he doesn't want to initiate the alarm activation. He would prefer that the alarm would not activate at all. The alarm activation is a spontaneous event that is caused by a consolidation algorithm over its detector. So the system has some wisdom that checks the detectors all the time and decides when there is a situation that may cause to set up the alarm, to activate the alarm. So if we think that there is a use case that's called burglary alert, it is not for the burglar. The burglar does not need to activate a use case, does not benefit from activating a burglary alert. Who does benefit from it? The owner, of course. So the owner could be a stakeholder whose interest, the benefit that he gets, is that the guard center is alerted when there is a suspicion of burglary. So when the guard center gets an alert or when the horn is blown, it's not necessarily says that there is a burglar inside. It said that there is a suspicion of burglary. Maybe it was caused by a lightning or by a spot on the detector. And the last point, the owner may be the primary actor, but of another system use case. For example, system setting. So system setting is another use case that enables the alarm owner, the house owner, to set up the system. The final result of the setting up is that the system is ready to operate the consolidation algorithm and decide when there is a case to blow the horn or to call the guard center. So if we are looking at a sample use case diagram for this, we can say that the alarm system can have two use cases, system setting and burglary alert. System setting, the primary actor is the owner, operates it, and the burglary alert doesn't have a primary actor, so it is a spontaneous use case that activates the guard center by sending it some indication. Also, it may blow the horn, but the horn is part of the system itself. We'll talk about it in a minute. And by this, it satisfies the needs of the owner. The owner is now benefits from the system that sent some indication to the guard center. Now here's another question. There are detectors, and there is the horn. Should they be shown in the diagram? Why are not they shown in the diagram, in the use case diagram? Look at the use case diagram again. We don't see the horn and the detectors here. Should they be shown here? That's a good question. And the answer is depends. Let's ask an alternative question. Are the detectors and the horn part of the system or entities of the environment? Well, this depends. It depends on what we define as the system. On the left-hand side, you see the alarm system as a whole, which includes its panel, its computer, its detectors, the horn, as a whole system, and it's called an alarm system. So the use case of burglary alert is a use case of the alarm system, and since it is an internal or spontaneous use case, it is done with all the parts that are inside the system. But if we wanted to model only the alarm computer, we should define the frame, the system frame, as the alarm computer only, and then the detectors and the horn are outside. They are part of the environment. Actually, they are supporting actors. The detectors are supporting actors because the burglary alert in a loop samples the detectors and then initiates or activates the consolidation algorithm all the time. And when the algorithm decides that the horn should be blown, then it may activate the horn and blow it and sound it. So in that case, the detectors and the horn are outside the system. But the system is different here. Here's the alarm computer and here's the alarm system. Let me take another example to make this issue clear, because this is a very, very critical, crucial issue. Think about a use case called cash withdrawal. You want to withdraw some cash from the bank, from your account. Now, if you are modeling the business logic of a bank contains branches, contains ATMs, contains tellers, contains computerized systems, contains everything. And the client is an entity of the external environment. It is a user of the bank, and it wants to operate a cash withdrawal use case. He wants to withdraw some cash. And then a description of the process that's called cash withdrawal could define how the client can withdraw the cash with two alternatives, one with the assistance of a teller and another with the assistance of the ATM. But both the teller and the ATM are part of the bank. So the bank is the business system here, and the client is from the outside. But if you are developing an ATM, so the ATM is your system. So the cash withdrawal use case now has two entities in its environment. There is the client, who is the operator, who initiates the cash withdrawal by inserting the card and doing all the dialogues required by the system. But the ATM itself cannot decide whether the client is authorized to withdraw the amount of money that it wants. So it has to apply to an external entity in the external environment, which is the data server of the bank. The cash withdrawal use case will ask or will communicate with the data server and get an answer whether it can or cannot issue the amount that was required by the client. Now take a third case. When you are developing the application for the teller. When you develop the application of the teller, the person or the user that activates the system is not the client, because the client has no access to the teller. Actually, the user of the cash withdrawal use case is the teller. it does it when it is asked orally by a client, but the client does not touch the system at this point, does not activate the cash withdrawal. Now, in order to apply or to fulfill the cash withdrawal, the application should contact the data server to get information about the account. And then when the information is positive, it will apply to the client and ask the client to sign off the digital board that is there. So the client here is a supporting actor, because without its signature, the task will not be completed. So there is one primary actor, the teller, and two supporting actors. One is the data server and the other one is a client. Look, that the client is a supporting actor here, whereas it was a primary actor in this context and the primary actor in this context. So this is very important to see. Although the use case has the same name, cash withdrawal, in all three cases, the context or the system in discussion is different. So this changes the whole representation of the use case diagram. Now, one more question. We know in agile methods and in Scrum, for example, there is something that's called a user story. And the agile processes is based on the idea that when you want to add a feature to the system, you write a new user story, and the user story should help you to know what to do in order to add this feature to the system. Now, we saw use cases here. Use cases are also processes that the system has to do. Now, what's the difference between a use case and a user stories? Let's take a look. In order to get the answer, we have to understand what is a use case specification. Use case specification should contain a lot of information about how the use case, that was named in an ellipse, how does it operate? In order to understand it, let's look at this. A use case can be successful or not. If you want to withdraw money from the ATM, then either you get your money or you don't get your money, you don't get your card back, and everything fails. So the use case is successful when, first, the primary actors achieve their goals. So you are the primary actors, you are the primary actor, you are the user, you want to get $100, okay? But also the stakeholders' interests were fulfilled. Who are the stakeholders here? For example, the bank itself is not an actor. It doesn't play in the game, it doesn't activate, it doesn't interact with the system, but it has interest. It has to benefit from your withdrawal. It has to collect the interest. It has to collect the commission. It has to know that your withdrawal was recorded on your statement. Okay, so it has interest. The system has to fulfill these interests. So if we are talking about primary actors that have goals and stakeholders that have interests, then the use case is successful when these two conditions are satisfied. These conditions are usually called the post conditions. Post conditions are the results of a success. So whenever we specify a use case, we need to set up the post conditions to specify what are the post conditions that need to be achieved by the use case. Now let's start from the beginning. You go on the street and you want to use an ATM. You see an ATM and you say, well, that's a good time to have some cash in the pocket. There are some conditions under which you will not be able, or you will be able to go and try withdraw some cash from the ATM. One condition is that you have a card. If you don't have a card, then you cannot even dream about getting some money from the ATM. The other condition is that the ATM is operative. If you see that it is said out of order, then you can only dream about your cash, you will not use the ATM. Is the knowledge or your knowledge of your PIN code, is it a precondition? Not necessarily, because you think that you know the PIN code. Once you type it in, maybe you will not do it correctly. Maybe you forgot. Maybe it's not the right card. But so this is not a precondition. Precondition is something. If you don't have a card and the ATM is not operative, then you cannot use it. But if these two conditions are enabled or are in place, so you can apply a trigger. So you can initiate, you can do some event of the use case to initiate the process of withdrawal. In this example, you just insert in the card. Okay, so you insert in the card, and then the process starts. Now, the process starts by asking you to enter your PIN code. You enter your PIN code, and then maybe your PIN code is correct, maybe it is not. If it is not correct in the first time, you get another opportunity to type it again, and then it is checked again, and then if it is your second opportunity, you get the third and last opportunity. If it was the third and last opportunity, you will not get your card back, and your post conditions will not be satisfied. But if the PIN was correct from the beginning, then you get into the system. How do you deal with all this mess of conditions and subconditions? The idea behind writing use cases is to think about the shortest and ideal way to get from the trigger to the post conditions. This way is called the main success scenario. Main success scenario is the ideal and shortest scenario leading to success, which means the interaction is the system asks the user to enter a PIN code. The user enters a PIN code. The system verifies the PIN codes, not checks, because if it is checked, then it may be correct or not correct. So the success is the system verifies the PIN code. Then the system asks the user to input the amount needed. The user types in the amount. The system checks with the bank, with the database of the bank, that the user is allowed to withdraw this amount. Also, the system has to check that it can fulfill it by means of that it has enough cash, and it has the right bills, etc. Then the system verifies these two things and then issues the cash. The user takes the cash, and then the system records it on the statement and collects the commission, and then it is ended. The scenario is ended. When the scenario is ended, we have to ask ourselves whether we achieved the post conditions. In this case, if the scenario contains a step of dispensing the cash to the user, then the first condition was successful. And then if the system succeeded to record the transaction on the database and to collect the commission, then the second condition, post condition, was achieved, and that's it. So this was successful, but this is only the main success scenario. Now what happens if, now let's go back and think what can happen on the way. What can happen on the way is that the user was mistaken in the first attempt of entering his PIN code, and then he got another opportunity, and then he was entering the right PIN code, and then the scenario can continue and the post conditions will be achieved. This is something that we can call an alternative. An alternative is a different scenario that leading to success. It's not the shortest, it's not the ideal, but it is another scenario that leads to success. But if we think on other cases or other scenarios, there could be a scenario that the user is mistaken in all three attempts. In that case, the machine will not return the card, and the machine will not dispense any money. And this kind of scenario is called an exception. An exception is a scenario that leading to failure. So, in order to give a full specification of a use case, we need to specify all of this, because this this describes all the behaviors that are expected from the system. Now, if we look at use stories, as in Agile, they are not use cases. User story is of the form, if you look at one of the gurus of user stories, Mike Cohen, if you look at his website, a user story is of the form as a type of user, I want something so that something will happen. There is some reason. What is there in this sentence, in this story? There are three things. One is the primary actor, the type of user, the user that operates. The other is the actor's goal. He wants to get something. Now, what is the some reason? Is it a post condition? Is it something that happens and enables other entities? Or is it a stakeholder's benefit? It's hard to tell. Some reason, maybe a rationale for the goal, but it's not clear whether it should give benefits to other entities. In any case, a user story does not answer other questions. For example, how to initiate the story. I want to do this. How do I do this? Under which circumstances? For example, can I buy something on eBay website? The answer could be yes, but it could also be no, because in order to buy something, you have a precondition that you have surfed into or you have connected to the website. If you are on the website and the correct page is displayed, then you may buy something. But you cannot buy something if you don't have this precondition in place. So these are the circumstances under which you can operate. Now, what is the interaction between the user and the system during the story? We saw that there is a whole interaction. The system asks something, the user provides something, the system asks another thing, the user provides another thing. What's the ideal? And what are the alternatives and the exceptions? Are there alternative ways to achieve the goal? What happens if the goal is not achieved? Does it get the money back? Does it get the card? Is it cancelled? Is it kept on file? Whatever. This is not specified by a user story. Now, you could say, well, actually, these are not requirements. This is sort of implementation. Okay, this is an interesting argument, whether these are requirements or these are implementations. It depends on which viewpoint you are looking at it. This is not covered in this webinar, but it can be covered, or it will be covered in other tutorials that I provide. I'll give you a list at the end. So the last question: what's the contribution of use cases to later life cycle stages? Because in many companies, you see that people write use cases, but then they put them aside and say, okay, this was written for the protocol, they are somewhere there, and nobody is interested in them. Well, use cases have much importance in the later life cycle stages. For example, use cases are the basic of the functional architecture. What's a functional architecture? The functional architecture is built through a process that is called in the standards of systems engineering and software engineering, is called functional analysis. What is a functional analysis? In functional analysis, you examine a defined function. For example, let's take use case as a defined function, something withdrawing cash. Okay? Now, you want to identify all the sub-functions necessary to accomplish this function. Actually, if you look at the description of a use case, as we saw before, there are functions that are done by the system. The system asks questions, the system contacts the database, the system calculates money, the system does something, operates something. All these are sub-functions. So you identify all the sub-functions, and then you have to identify functional relationships and interfaces, which means that you have to find a set of functional components and the connections between them, like the algorithm, the user interface, the cash counting machine interface, the card reader, and other components that are operating together in order to achieve the use case. So once you identify these components and the internal and external interfaces, internal how they connect to each other and external how they connect to the external world, then what you do is you can flow down the upper level performance and other non-functional and functional requirements, and to assign these requirements to lower level sub-functions. So to say that this is done by the user interface component, this is done by the calculating component, this is done by the communication component, etc., etc. So at the end of the day, the functional architecture will include all these features, all these components that will be the building blocks of the system. Now, in order to understand how these components work, for example, here we have an elevator system with a central command and control component and an elevator command control component, which is the software of the elevator, and this is the software of the central computer. Okay, we can translate this use case that we specify the system as a whole. Now we can translate it into interaction between the components that we identify. So these are the functional components obtained through the functional analysis that we saw before. This is something of the external environment. And the sequence diagram, this model, without getting into too many details, can show all the interaction. So there is a request coming from, for example, if you want to call an elevator, you press a button at the floor panel, at the button to one of the floors. Then the request goes to the central computer. The central component checks with all the elevators who is the one that should be allocated. And then it will select an elevator and allocates this elevator, tell this elevator, take this ride, okay? The elevator will say, okay, and then it will, the central command and control will switch the button at the floor, okay? And then the system loops the process of driving to a floor, opening the door, driving to a floor, opening the door, until that there should be that the floor was obtained for all requested floors until my floor. When it comes to my floor, it notifies the elevator, notifies the central command control I have arrived to that floor, and then the central command control will turn off the button on the wall. Okay, so this is how the use case is now performed as an interaction among the functional components that we identify through the functional analysis. Now, when coming to tests, actually, writing use cases is a sort of test-driven development. Because when you write use cases, you specify everything that in the testing will be done in the test cases. Look, for example, on this simple test case form of an ATM. In order, what is this form for? This form is directions for a tester how to test the system. So the system is the ATM. The test is changing the pin, or the operation, the use case, or the function is changing the pin, and the test is test the ATM, change pin service. You see that there are preconditions. The user has a valid ATM card. The current pin is 1234. The system displays the main menu. All these are preconditions without which it cannot be performed. And then the steps. If we specify the steps of the use case, of the scenarios, here are the steps of the test. Click the change pin button, and then what is expected, which means the results. Enter 5555. What is the result? And re-enter 5555. Again, all this interaction, what does the tester do, the user in this case? What does the system do? And then there is the post condition. The new pin 5555 is saved in the database. So this is the post condition. So once you write the use cases, you save a lot of work to the testers, because they are going to test the system. The test cases are actually variations of the use cases. So this saves a lot of time. Now, the final question: who should write the system use cases? Who are the persons to write the system use cases? Are these the software people, the systems people, the human engineering people, the clients, maybe? Well, let's think about how a system is built, or how a system, or how the use cases are performed. System has business logic, has users, can operate in a system of system environment, has quality attributes, has constraints, has all this cloud of information. The experts of these informations, or let's say this information, is the background from which the system use cases are derived. What are the system use cases? They are specification of the processes through which the system provides its services to the external environment. This is what our use cases are. And once these are specified, software can implement, software or firmware or other sort of implementation can implement those things. And here are the software engineers who are experts to do this. So if we look at the people involved, systems engineering is involved, it understands very well the external environment and the business logic and all these sort of things. But as long as the development process proceeds and goes down into the software, they are less involved, the systems engineers. However, software engineers, they are very much involved in software implementation. They are experts of the techniques, of the software techniques and everything. But not always they understand where did they come from. So they take it from here, from somewhere here, and go down to the implementation. Now the system use cases fall in between the two disciplines. So a system use case writing must be a shared challenge of both the system and software engineers. So the system engineers that come from above and the software engineers who go down, they need to meet somehow here and together to write the system use cases. So this concludes our webinar, and I would like to thank you all for listening. Thank you very much.